Hello, my name is Ching-Tai, and apologies for not being able to be there present today, but I'd love to present to you my master's dissertation. I recently graduated from UCL with an MEng in Engineering Architectural Design, and today my dissertation is about Kintsugi, repairing gaps within the Victorian home, and integration of aesthetics and performance. Going straight right into the introduction of my presentation, when talking about the housing stock within the UK, 21% of the UK housing stock is historic, which is great, but this is a barrier to our net zero goals as a country. And a lot of the building stock within the UK was built during the Victorian era, where a huge architectural element is the timber sash window, which is beautiful. They're single hung and they're very functional for allowing ventilation. They're architectural beauties, but they prove to be quite air leaky. And so our instinct is to kind of replace these windows with new PVC panels that are double glazed. However, they lose kind of an architectural charm to these historic buildings. And so rather than replacing it, we should repair. However, nowadays, our repairs are rooted in functionality, and we don't really consider the beauty or the aesthetic value of these repairs. And so my dissertation is to kind of flip this narrative in introducing the idea of kintsugi, where a broken plate is broken into pieces and it's put back together, and the repairs are made visible with a kind of a thin coat of gold paint. And so this proves to be a functional repair, but also rooted in aesthetics. And that is what I intend to do with a timber sash window. In my literature review, conservation bodies such as SPAB and English Heritage stress repair over replacement. And a technical study done by English Heritage in 2009 suggested that draughtproofing can reduce air leakage by 86% in a timber sash window. However, this value was singular, and my research aims to compare and evaluate this value with the different interventions. And throughout the literature review, I recognize that in retrofit research, there is a gap in introducing and integrating aesthetics. And so going into the draft proofing interventions that I would like to test, I have 6 interventions that are all commercially available to homeowners. And my intention and aim is to see these repairs as both technical enhancements and aesthetic enrichments to the historic timber sash window that I'm testing. So I have foam, brush seal, V-seal, E-profile, secondary foam, and spring bronze. In my methodology, because there is this dual analysis that I would like to complete, there is a qualitative side and a quantitative side. In a quantitative side, I am testing the airtightness performance, and I did through to 2 main methods, a fan pressurization method and a CO2 decay. The fan pressurization, it tests the high pressures, and the CO2 decay tests the infiltration rate, and these results cross-validate each other. In terms of the qualitative side, there is the aesthetic value. I completed a survey with 100 participants with a questionnaire and completed principal component analysis and clustering to recognize with different aesthetic values what intervention they preferred with their aesthetic value. In the results, compared to the precedent study, looking at the window in isolation without the airtightness box as a system, the only close intervention that was close to replicating the 86% value in reducing air leakage was the foam strip with 84%. All of the interventions were not close to replicating this value from English Heritage. In terms of the actual performance as a system, however, the most efficient intervention was the brush seal, with the spring bronze being the least efficient when taking the averages of the air leakage reduction of the high pressurization method and the tracer gas method together. In terms of the aesthetics, through the 3 different clusters of valuing historians, realists, and expressionists, overall, the spring bronze was the most efficient and aesthetically pleasing, with the secondary foam being the most visually intrusive. So, with the discussion of having to integrate and intersect the physical and aesthetic performance, I plotted the performance on the x-axis and the aesthetics on the y-axis from the previous results. And you can see from a range of 1 to 6, 1 being the best performing and 6 being the worst performing. This means that the closer to the origin the values are, the better and most integrated the kind of intervention is in terms of aesthetics and performance. And the only one closest to the origin throughout all different clusters of kind of aesthetic values of the 100 participants was the E profile. Brush seal performed the best, but it was ranked very low in terms of the aesthetic value. And looking at the bronze, kind of on the right, it had a very high aesthetic value, but it was the worst performing in terms of the physical performance. So the best balance was the E profile that provided technical and visual harmony, and it kind of suggests that throughout the kind of common and commercial products, there are interventions that are a little bit more integrated in terms of the aesthetic value. And so in conclusion, the right you can see the E profile and the left you can see an image of the Kintsugi. This suggests that at the end of the day, our repairs can be rooted in both technical and aesthetic values. And we can make very small changes to the built environment, but they can be opportunities to be a moment to storytell and layer history and celebrate the idea that we're using these kind of incredible historic buildings. Thank you very much.